A very good evening, everyone. I warmly welcome you this evening for the 17th Computer Engineering Seminar on Fundamentals of Bitcoin and Blockchain Technology, organized by ASUS, the Association of Computer Engineering Students at the Faculty of Engineering, University of Peradeniya. I'm Isuri Devindi, and I will be the moderator for this seminar today. In today's session, you will get a chance to learn about the fundamental concepts of blockchain and Bitcoin, the differences between Bitcoin and the traditional banking system, the factors that necessitate the use of blockchain, such as its decentralization and distribution, as well as the inner workings of blockchain technology, such as cryptography, transactions in Bitcoin, and consensus mechanism. The resource person for today is Dr. Nguyen Trong, who is currently an assistant professor at the School of Computing Science, University of Glasgow, UK. He was a research associate at the Data Science Institute, Department of Computing, Imperial College London, UK, from 2018 to 2022. He received his PhD, MSc, and BSc degrees from the Liverpool John Moores University, UK, Pohang University of Science and Technology, Korea, and Hanoi University of Science and Technology, Vietnam in 2018, 2013, and 2008, respectively. He was a software engineer at Dasan Networks, a leading company in networking products and services in South Korea from 2012 to 2015. His research interests include, but are not limited to, data privacy, security and trust, personal data management, distributed systems, and blockchain. Before moving on to the session today, I would like to mention that you can raise your questions during the Q&A session at the end, either by using the Zoom chat box or by unmuting yourself. We'll also be sharing the link to a Slido event where you can raise your questions throughout the session. With that being said, without further ado, I would now like to invite Dr. Nguyen Trong to take over this session. Sir, over to you.
Thank you, Isuri. So, all right. Hello, everyone. I'm sharing my screen now. Let me check. That. Okay. All right. So can you see my screen now? Hello? Hello? Can you guys can see my screen?
Yes, sir.
Oh, cool. All right. So good afternoon, everyone. So as Isuri mentioned before, I'm Nguyen Trong, a lecturer, assistant professor in cybersecurity at the University of Glasgow, the United Kingdom. So today I would like to give you a short seminar about the fundamentals to Bitcoin and blockchain technology. So hope you guys here enjoy the talk and grab some basic knowledge about Bitcoin and blockchain technology as well. So I think it's already here. So I intended to introduce a bit about myself, but Isuri did, so I skipped this slide. Now let's get to the outline of the presentation. Okay. Oh, so let's get to the outline of the presentations. So it consists of 4 parts. So in the first part, I will briefly introduce the concept of Bitcoin, particularly in the comparisons with the traditional banking systems. The next section is to remind or to present some basic background on cryptography techniques, which is used in Bitcoin, which include like public key cryptography, digital signatures, hash functions, etc. So in the first section, this is one of the most important knowledge to be delivered in this seminar. is present about how Bitcoin work. Here is I try to introduce the underlying technology behind Bitcoin, and which is called blockchain technology. This section is quite long and it consists of 4 parts, as you can see here. The fourth session is to introduce some ongoing research direction related to the security and the privacy in Bitcoin and blockchain technology. And the last session is for section Q&A. So here comes the first part. So I'd like to give you some basic concept about Bitcoin. So what is Bitcoin? So I believe more of you guys here have heard about Bitcoin or cryptocurrency and blockchain technology. So basically, Bitcoin is a distributed, decentralized digital currency system. So it's a bank actually run by an ad hoc or peer-to-peer network. So it's not run by a central bank or any kind of commercial bank. And this bank also have some kind of similar concept of the central bank, like the digital check, a transaction log, but this is distributed. And the difference is that it runs by a peer-to-peer network consisting of the node running Bitcoin protocol. So the nodes here may be the lightweight node or the full node. And it released by the unknown name Satoshi Nakamoto in 2008. So it seemed quite a simple definition of Bitcoin, right? But the related concept and the underlying background knowledge is quite complicated. It ranges from cryptography techniques, networking and distributed systems, electronic cash system, and kind of new novel consensus mechanisms in distributed systems, and another factor like incentive scheme as well. So I'm going to introduce this underlying knowledge about Bitcoin and blockchain technology right now. So let's go through it step by step. So let's take a look at the history and the innovation of the payment system throughout the years. So as you can see in this figure, like it starts from a balance sheet long time ago in the ancient accounting system in Babylon, like 2000 before Christ. And then it advanced to the centralized banking systems through the Bank of America, HSBC, some payment system like Visa or Master. And then in 1983, a new kind of electronic cash system proposed by Count, which is the initial idea of cryptocurrency. It is called privacy preserving banking. This is kind of electronic banking system, but it also is not decentralized as in Bitcoin. And we go to the year of 2008, which is the introduction of Bitcoin, one of the most famous and successful cryptocurrency system until now. So what are the main differences between the traditional centralized banking systems, the central bank or the commercial bank, versus the decentralized payment system like the Bitcoin? So here I consider 3 main features, and you can see here in comparisons. The first one is the identity. So in the banking system, in the traditional centralized banking system, we have identities. Here is some kind of the account number, right? Short code and account number of your bank accounts. But in the decentralized banking system, like in Bitcoin, we don't have such kind of thing, but we have the identity. For example, here we have Bitcoin addresses. this is defined by the uses of the public key. I will mention a bit later, but that is different. So how in the centralized banking system, the authentication is important as well. How you can be authenticate that that identity belong to you. So in the central banking system, we use the physical bank card, or we use the internet mobile banking account with the username and password. But in the Bitcoin systems, we use digital signature for the authentication of your identity. And the third one is the transactions. So the transaction is verified and recorded onto the ledgers by commercial or central bank in the banking system. But the transaction in Bitcoin is different. It is verified and recorded onto distributed ledgers. We call it Bitcoin blockchain by the node, by the participant nodes in the peer-to-peer network. So, you can see a bit about the difference between the centralized payment system and the Bitcoin payment system, right? Okay. So here, the common thing is that in the centralized payment system and in the Bitcoin payment system, we all have the ledgers. So ledgers is kind of locked by recording all of the transactions in the systems. And I'm going to present a bit about the Bitcoin ledgers. So the Bitcoin ledger here is composed by a chain of block. You can see here the ledgers here consist of a chain of block in which the current block is linked with the previous block using the hash of the previous block header. So if you can see in the figures, so that's why we call it the blockchain, which means the chains of block. So the ledgers in the blockchain is here, the chains of block, compared to the ledgers in the centralized banking system like this, record all the information about transactions. So we're going to go into detail about how Bitcoin and blockchain technology work in the next few slides. Okay, so before going to detail how Bitcoin works, so I would like to present, to remind about the underlying cryptography using Bitcoin. So the first thing is the public key cryptography. So this in the public key cryptography, so as I mentioned before, it used for the Bitcoin addresses or for the identity of the user in Bitcoin system. So in Bitcoin, we use the public key pair consisting of the one public key and one private key for a users. And actually we use the elliptic curve, this one, the ZP 256K1 for the public key pairs to the user identity. So I hope you guys know about that. I don't need to explain it more. And for the authentication authorizations of the identity, the public key, we use a digital signature scheme. So in Bitcoin, we use elliptic curve digital signature algorithms, which is the ECDSA, which is a cryptographic algorithm used by Bitcoin to ensure that all the payment can, all the funds can only be spent by the right owners. So the digital signatures to ensure that. So this digital signature scheme dependent on the curve, elliptic curve, and the hash function is used for that as well. So in Bitcoin, it is this SECP 256K1, and the cryptographic hash function is SHA 256 for the authentication and verification of the transaction in Bitcoin. So I also hope that you guys have knowledge about this one. So by using the digital signatures, we make sure that the payment in Bitcoin systems is authenticated securely, and also it provides the integrity and the non-repudiation in Bitcoin payment system. And there's we use a lot of hash function in Bitcoin systems. For example, when we generate the Bitcoin addresses, is it the hash of the public key of the users? So as I said before, we use the SHA 256 hash functions, which is one of the most famous cryptographic hash functions to be used in the reality. And the hash function have to make sure that it is the function to be used to map the data of arbitrary size to a fixed size values. For example, to 256 bits, the value returned by hash functions called hash values, or hash code, or dice hash, or simply hashes. And a cryptographic hash function must have this property that I list here: the consistency, the pre-image resistance, and the second pre-image resistance, and the collision resistance as well. So the detail of the properties of the hash functions. Okay, so we have three main techniques used in Bitcoin: the cryptography, encryption, key pair encryption for the user identity. This is the signatures for authentication and verification of the transactions. And the hash function used a lot in generating Bitcoin addresses and in the verification of transaction as well. Okay, so now let's assume that we have some knowledge about cryptographic techniques used in Bitcoin. And now we are going back to the Bitcoin and how Bitcoin work. And generally, to enable Bitcoin, we have to answer three general questions. The first one is how to securely perform decentralized payment in Bitcoin. In other words, how to operate the Bitcoin digital currency system in a decentralized manner. So before Bitcoin that I mentioned previously, so existing digital currency system have been introduced by David Kampf in 1983, for example, but it never taken off because a lot of difficulty happened, and also that payment system have to be dependent on a central bank as well. So it's not decentralized payment system. So how Bitcoin can overcome such challenge? And the second question is that how we can, exchange the privacy preserving payments in Bitcoin systems, or how to make sure that the privacy of the payment in the Bitcoin systems. And lastly is how to make that system more efficient. For example, we need to ensure the throughput, the number of transactions per second, etc. So in order to answer that three questions, Bitcoin protocol is introduced. So I'm going to present the detail of the Bitcoin protocol in the next section. Okay. So this section for Bitcoin protocol consists of 4 parts: the Bitcoin addresses, the ledgers in the Bitcoin payment systems, the transactions when you make payment in Bitcoin systems, and one of the core function in the Bitcoin protocol is the consensus mechanism called the proof of work. So okay. So the first important thing is the identity of the users in Bitcoin systems, which is called Bitcoin addresses. So as I mentioned before, it's user or the private and a public key pair, right? And the Bitcoin addresses, which is public to the world, is generated from the the user public key. So it actually the hash of a public key, and this is unique identifier because of the property of the hash, right? The hash functions. This is an example of the Bitcoin addresses. It is similar to your bank account shortcode in the payment system, in the centralized payment systems. And here's how can we generate the Bitcoin addresses from the public key. And then another important concept is the ledgers in Bitcoin. So the Bitcoin ledgers is a chain of block, right? It's a chain of block called the blockchains. And each block contains a header and the list of transactions. And the nodes in the peer-to-peer Bitcoin network are expected to store exactly the same ledgers in their local storage. And that is how we ensure all the nodes reach the consensus. So all the nodes are expected to have the same version of the ledgers in their local storage. And how we can make sure how we can do that, I'm going to talk a bit about later. But now we go a bit into detail about the Bitcoin block. Okay, so let's see here. The Bitcoin blockchain consists of the chains of block, and what here is information of one block. So each block contains the header and the list of transactions. Okay, so the header is serialized in the 80 bytes format, consisting of some information about the versions, the previous block header hash, which is used to connect the current block with the previous block. So this ensures no previous block can be changed without also changing this block headers. So it's the content of the header. The header also have the Merkle root hash. So hope you heard about that before, but all right. And the time of the how can I say, the time when the block is generated, and the number nonce, number used ones. So the nonce is an arbitrary number that the Bitcoin miner changed to modify the header hash, in order to produce a hash less than a target threshold. But it's quite complicated, and I will explain it in the consensus mechanism later. All right. So here, one block have header and transaction, and now the content of the transactions. So the transaction, it calls as how the transaction are stored in the block. So the transactions use a data structure called the Merkle tree. So the Merkle tree is kind of the hash tree. Is the tree data structures in which every leaf node is labeled with the cryptographic hash of the data block. So every node that is not a leaf is labeled with the cryptographic hash of the label of each child node. So as you can see here, is how the transaction is organized using the data structure Merkle tree. So this makes sure that if any transaction is modified, then this root hash is changed. So if we modify any kind of transaction, this one will change. So so the header also change. So it will, result in the change of all of the previous block, which invalidate the blockchain. Okay. So basically, we understand what is block in the Bitcoin blockchain ledger, right? Consisting of the header and the list of transactions organized in the data structure Merkle tree. So now is what are transactions? We go into transaction in Bitcoin. So in order to transfer a Bitcoin from, for example, here from Alice to Bob, so we have to make the transaction and broadcast this transaction to the peer-to-peer network. So for this transaction, for example, this transactions records the information of the transfer 0.25 Bitcoin from Alice to Bob. So in the transaction here, we have to specify two types of information. One is the input, which is the Alice address, which is the Alice address also specify the Alice balance, the number of Bitcoin that Alice currently owns, and the output, the movement of the Alice balance to Bob balance. So here's Alice balance, and the recipient address is the Bob address, and the chain's addresses, which is belong to Alice as well. So here the detailed structure of a Bitcoin transactions. As I mentioned here, we have the transaction input, which is the which is belong to Alice, and Alice have to need to claim that she has one Bitcoin in her balance by showing the output of the previous transactions belong to her. So to do that, Alice needs to use her private key to generate her digital signatures. So, and here the output, so the output quite a bit different. The output is like how can I say, a script used to define the condition using a scripting system defined in Bitcoin, and the condition must be satisfied in order to spend the output in the next transaction. So if the output is belong to Bob, so Bob have the his private key, and his private key can be used to claim that this output belong to Bob in the next transaction when Bob want to transfer that money to another person. So here the details, the content of Bitcoin transaction with one input and two outputs, and the transaction verification using Bitcoin's scripting system, using some operations like here. It's quite detailed and complicated. And to do so, in Bitcoin system, they have to define a scripting language. I call it the scripting system in Bitcoin, which is a stack-based programming language. And if this is defined the script in this format, and it defines many opcodes, and it's the execution time is critical as well in this programming language in order to prevent the DOS attack in Bitcoin payment systems. So another transaction here, because the transaction in Bitcoin is quite complicated. So another transaction here is we have, for example, Alice, after the transaction want to transfer another 0.5 Bitcoin to Eve here. I call it transaction 2, and she has to claim the output of the transaction 1 and the input of the transaction 2, and so on, right? So after transaction 1, Alice balance have only 0.75 Bitcoin, and Alice need to claim that this belongs to me, and it will be the input of the next transaction, transaction 2. And this happens so on and so on. So, okay, so that is how the whole structure of transaction in Bitcoin and the block in the Bitcoin blockchain. Okay, so let's move on how a new block is updated or is appended to the blockchain ledgers. This is called the consensus mechanisms or consensus protocol. So I think probably many of you guys here heard about the term proof of work in Bitcoin. So let's see what it is. So Bitcoin, is a distributed ledger blockchain. So therefore, we have to make sure that information added to the ledgers must be accurate and honest, and the entire network have to agree with the content of the ledgers. Here, the new block, right? So a mechanism for all the nodes in the Bitcoin network to cooperate and to reach a common opinion. Here, the reach to the consensus, called the consensus mechanisms. So in the consensus mechanism, we have to make sure that all the nodes reach agreement on adding a new block to the existing ledgers, the existing blockchains. So we have to make sure that in that block, in that new block, all the transactions are verified and all the content of the block is not falsified, right? And this new block will be approved by all the nodes in the network. And that mechanism also keep all the nodes in the network synchronized. So when a new block is approved validated, all the nodes can validate the block and validate all the transactions record in the block by verifying the signatures provided in the transactions. Okay, so basically I introduce all the information in a Bitcoin block except one term, the nonce. Okay, so I remind here the block. Here's the Bitcoin block. All the information we know the headers, we know the root hash of the Merkle tree for the list of transactions. Okay, and except the nonce. So what is a nonce? So the nonce in the Bitcoin block is the 4-byte field, which values are trusted by the Bitcoin miners. So that new concept, the Bitcoin miners, so that the hash of this block will be less than the current target of the network. So if you read more a bit detail about how the Bitcoin protocol, you will know all of the concepts behind that. So basically, all the miners in the Bitcoin network have to find this number, the nonce numbers, in order to make sure that the hash of the block header is less than the target. So the target here is represents the difficulty of the mining task. So where a higher difficulty represent a lower target. And this, this calculation of the nonce of this number require time and resources. The representation of block with the correct nonce values, it constitutes the proof of work. So if any miner can find the nonce, it shows that, okay, this is my proof of work to, to find the nonce, and I have the right to put this block to the current blockchain. So the thing is that there is no way to guess this nonce number. So it's a belief that it's infeasible to predict which combination of bit will result in the right hash. So we have to, brute force run it, try to get the nonce, to get the correct nonce. And every nonce, the hash will be recomputed for its value until the hash less than the target. So it maybe requires like millions of tries. So that's why mining a block in the Bitcoin system is really hard. And there is no way to guess that. The only way is using the brute force to get the nonce. So I want to present a bit about how to get the nonce. So we have the hash of the header, including the nonce here, and must be less than a target like this. So we try with different option of the nonce here. So for the first one, is this resulting in the hash is larger than the target. The second one also larger than the target, and the third one with this nonce, it is less than the target, right? It's start with 00000 is something like that. So in this case, the miner successfully find the nonce, and as a result, the miner has the right to form a new block, and that miner claims his work by broadcasting this new block to the entire network here. So the property is that the verification is very easy to get the hash and see that, okay, all right, the nonce is correct because it's less than the target. But how to find the nonce is hard. So that is a property of the proof of work mechanisms. Verification is easy, but the work is very hard. So not so many miners can get the work done. So if it's done, it will immediately broadcast the new block to the entire network. So there probably a problem here is that what happens if some miners successfully get the nonce or calculate the nonce at the same time, or approximately get it in the same time, and broadcast their own new block to the network. So it usually happens due to a huge network or a lot of miners with a powerful computations, or due to the transmission of the broadcast of the new block takes time. And the miner B in this scenario, so the miner A here and the miner B here, both of them are successfully calculates the nonce, and both of them broadcast the new blocks to the network, right? So consider the node A, the node X, and node Y in the network. So X receives the new block from the miner A first, right? So consequently, it will receive the new block. When it receives the new block from the miner B, it will draw this block because it gets the block from the miner A first. On the other hand, the node Y here, it receives the block from B first, and thus it will discard the block from the miner A. So this will create two different blockchain in the network. So this is called the forks. Okay. So it creates a different type blockchain because of the difference when broadcasting the new block from miner A and miner B. So at this point of time, there are two blockchains in the network. So how can we overcome that? Because we have to make sure that all the nodes in the network have to be to all the same blockchains. So that's all right. So in the blockchain, in the Bitcoin protocol, they define a rule called the longest chain rule. So that's all right. But let's consider the next block. For instance, the miner C computes another nonce for the next block. So the current blockchains of the miner C contain the block from the miner A, for example, and the miner C might on this blockchain. So miner C, the miner C here, the blockchain from the miner C received from the miner A in the previous block, right? And the miner C work on that blockchain and produce a new block. And then when miner C broadcasts its new block to the whole network, the node Y, for example, it broadcasts to the node Y. Okay. So the node Y will have to discard its current block and must have accept the new blockchain from the miner C. So this is called the longest chain rule. So in other words, the previous blocks from the miner B will be discarded because the next block is mined based on the block from the miner A, and that block discarded is called the orphan block. So eventually, using the longest chain rule, eventually all the nodes will have the same blockchain, which is the longest one. Okay. Okay, so that is how the Bitcoin protocol works. So I would like to remind you about the Bitcoin protocol consisting of a Bitcoin addresses, the identity for the users, the Bitcoin ledgers consisting of a chain of block called blockchains. In the chain of block, each block have the header and the transactions. So this is the content of the header and the transaction organized in one block. Okay. Here's the content of the transactions and how the transaction is made. And the heart of the protocol is the consensus mechanisms to make sure that all the nodes in the Bitcoin network will reach the consensus, reach all the unique ledgers, and all the nodes will be synchronized. So this consensus mechanism called proof of work is how the proof of work operates by guessing the nonce number and how the miner can broadcast the new blocks to the network, which is related to the longest chain rules defined in the protocol. Okay, so that's everything for Bitcoin protocol, and the next section is the current research on the Bitcoin security and privacy. Okay, so basically we understand the Bitcoin protocol. So now let's consider some security challenges in Bitcoin. So the first two challenges, like authentications and availability, can be nicely solved by the public key cryptography and the peer-to-peer network protocols, broadcasting messages to the peer-to-peer networks. We base on the peer-to-peer network protocols already developed for a long time. Now we are focusing on the two challenges is here the integrity and the confidentiality. So the integrity means if the coin can be double spent, or can attacker can reverse or change the values of the transactions. The confidentiality is related to the pseudo like privacy of the users. So are all transactions in Bitcoin private? How to make sure that no one can figure out who is real owners of the transactions. Okay. So the question is that why do we need to use a very extremely resource-intensive computation to calculate the nonce for the proof of work? So this is because this is how we make sure the integrity in the Bitcoin systems. So integrity is to prevent the transactions from the alterations and the double spend as well. So, intuitively, to change or to reverse the transactions, a miner need to recompute all the nonce for the previous block, right? And why it also need to raise with other honest miners for new blocks. So this is nearly impossible. So, like according to a Cambridge Center for Alternative Finance, the Bitcoin currency like consumes around how many? 110 terawatt hour per year. So it's like I have 0.5 global electricity productions, and it's equivalent to the annual energy consumed by Sweden or Malaysia. So you can see that it's really, really, electricity consuming. But currently, Bitcoin have no other choice for the consensus mechanisms. For the double spend problem, so we know that double spend problem is somehow one funds can be spent twice. So here's the strategies for attacker to perform a double spend attack. So that is how a double spend can be happens. So attacker make a transaction transferring its money to a victim, for example, victim V. So that attackers. So it mines a new block container of this transaction, right? A new block is appended to the blockchain, and the victim V, see here, can see the block has been confirmed. So the victim will hand over his goods. For instance, a Tesla car, for example, like the attacker transfer Bitcoin to victim V, and victim V can see that, okay, my transaction has been appended to the blockchain, and the victim V will, in return, for example, hand over the goods. So once the attacker get the good, it immediately, make another transaction with its money to another attacker account, and it's also mined a new block and append it to the blockchain, and it will broadcast it blockchains to the entire network. And because of the longest chain win, it can, it can mine 2 blocks at the same time, and because of that, this blockchain will be rejected, and this blockchain is longer because it's 2 blockchains at once, 2 new blocks at once, so it will be approved. So in other words, the transaction will be the transaction from the attacker to the victim field will be invalidated. That is how a double spend work. So the attacker successfully carry out the double spend in this case, but it's not possible in Bitcoin because in order to do that, the attacker have to mine two new blocks quicker than the entire honest miners, which is practically impossible thanks to the proof of work mechanisms. So the attacker can do that if it have the computational power than all of the honest miners in the network, which is assumed to be impractical. So the double spend attack is actually a race between the attackers and the honest miners. But at this moment, there's still a worry about that because all of the miners team up to form, they call it the mining pool. So all of the miners is not working independently, but they team up in order to to find the number more quickly. So they form a different mining pools. The mining pools, this is the figure about the mining pools, and as we can see here, just 4 mining pools. If the 4 mining pools here team up, they have more than 50%, computational power in the whole network. So what happened if the 4 mining pools collude in order to use the double spend attack? So that is possible. In this case, possible. So theoretically speaking, if the big mining so we are also with this confidentiality, which is related to user privacy. So basically, Bitcoin user don't want to reveal their activities in the Bitcoin network, right? Because Bitcoin ledger contain of the all transactions balance. So here we have Bitcoin is some kind of pseudo anonymous. This is because the Bitcoin addresses is like a random string of characters. But what's wrong here? So remember the transaction from Alice to Bob and Alice to Eve. So we can see that the Alice Bitcoin are related to each other due to the definition of the transaction. So Alice transferred to Bob here, and the remaining money of the remaining Bitcoin also belong to Alice, and this also spent in another transactions. And following this route, we can see that how Alice is spend her money. So if this combines with other sites information or low-layer network information like the IP addresses, there is an opportunity or there is a chance to figure out the real identity of the owners. So in order to do that, there are many solutions have been proposed. For example, they can use mixers, a joy coin, or the cat anonymity privacy, some zero knowledge proof mechanism also used to to prevent such kind of privacy leaking information. Okay, so that is also another direction for Bitcoin related research. Okay. So that's the end of the talk. Thank you guys for listening. And now it's for the Q&A sections. Thank you.
Thank you, sir, for sharing your informative and highly valuable knowledge with us. Audience, now it's your chance to clarify your doubts. You can either use the Zoom chat box, unmute yourself and speak up, or use the Slido link to direct your questions. We have two questions in the Slido Q&A chat box. I will read them out loud. Can you explain about smart contracts?
Okay, for smart contract is different. It's not in Bitcoin system. It's in kind of a new new kind of blockchain technology, like in Ethereum. So if you remember in my slides, in order to validate the transaction, or in order to spend the Bitcoin when making transactions in Bitcoin system, we have kind of a scripting language, right? Scripting language consisting of some opcodes. So smart contract is similar thing, but it expands the idea of using predefined opcodes. It will define kind of a Turing complete language, and you can program whatever you want. So all of the nodes in the network can run that smart contract and produce the same result, and that results will be appended to the ledgers. So that is basically what smart contract is.
There's another question. With increasing cyber threats, how can businesses rely on blockchain in the future, as any exploitation can directly affect the financial network?
That's how we can, that is how I present the research direction for the Bitcoin security. So a lot of proposals have been proposed in reality in order to strengthen the security of the blockchain or the Bitcoin payment systems. So you can refer that. But at the moment, it's just the early stage of the cryptocurrency systems, and it's a lot of work need to be done for both security and for the efficiency as well. So I can
thank you. There's another question.
Yeah, some questions. So I can read out the questions. The first one is, in proof of work, who define the target? Right, good. Is there a central authority to define the target? Yeah, in proof of work, actually the whole network define the target. So the target is set using a predefined code, hard code in the protocol. So they in the protocol, it observes the time between new block coming And if the time between the new block is too short, so for example, new block, every block occurs after 10 minutes, which is short, so it will increase the difficulty, the target. And in other hand, if the new block occurs more than 10 minutes, for example, that means the difficulty is really hard and the miner is still racing to produce the new block, so it automatically reduces the target. So the target is calculated based on the code, hard code in the protocol. So no one decided. Okay. So another question: Ethereum recently moved from proof of work to proof of stake. How will it affect security? Ethereum recently, officially moved from proof of work to proof of stake, like last 2 months. For the security, it will be no difference for the security because the bootstrap phase was based on the proof of work, and then they have a sufficient number of the users. So the continuation of the proof of stake, in my opinion, the security will be the same, but the difference is the decentralization of the Ethereum. So eventually, if you run the proof of stake, the decentralization will be decreased because all of the rich user, the user have a lot of Ethereum will have the ability to control the network. So it will eventually reduce the decentralization of the Ethereum, which is one of the challenge of the proof of stake. So another question: how does a transaction is mined to add a block, and how a set of transactions are selected to be included in block? So the mined is a transaction is not mined, but so whenever you have a transactions, the transaction will be broadcast to the whole network, and the miner will take the transaction and put it into the transaction pool. And basically, the miner will select a number of the transaction in their local transaction pool to form a block. And then in order to form a block, the miner need to calculate the nonce number, right, that I present, and how a set of transactions are selected to be, basically in the time that, how can I say, there's some kind of mechanism or algorithm to select a transactions to be included in a block, and it depends on the computation power of the miners. It can be selected by the time the transaction arrive, or it will be selected based on the size of the transactions. So different mechanism to do that. If you read carefully about Bitcoin protocol, you know that. Okay. So that, I don't see any other questions.
Hello, Nguyen. Can I ask one question?
Yeah, sure.
Nguyen, how about sentiment factors affect the cryptocurrency in the current domain? For example, recently Bitcoin dropped heavily, right, because of some of the facts, from well-known persons like Elon Musk, right? So is there any relation between these two, sentimental factors and Bitcoin currency price?
That you mentioned about is the kind of a financial aspect of the cryptocurrency, right?
Yes.
the price increasing, decreasing. I'm not really sure about that financial aspect.
But there's a relationship, right? Is it true? Is there research right now in this area?
No, I mean that is more related to some kind of financial research instead of blockchain research. That is how the price of the cryptocurrency work. I don't know. I don't have any idea about that.
Thank you. Yeah.
So looks like we don't have any more questions. As the Q&A session has come to an end, please rate today's session using the poll in the Slido link provided in the chat. Your feedback is highly valuable to improve the quality of these sessions. And once again, I would like to thank Dr. Nguyen Trong on behalf of SS. Sir, we sincerely thank you for taking time out of your busy schedule to join us and enhance the knowledge of this audience today. With that being said, we have come to the end of the session. Thank you all for actively participating in today's session and making it a huge success. While inviting all of you to join the upcoming seminars as well, let me conclude today's session. Thank you all for joining. Have a good night.
Thank you. Thank you.
Thanks.
Thanks. Bye.
Thank you, Nguyen.